watch it later, you're gonna wonder what I'm talking about. So yeah, quizzes have been graded, but I haven't released everything. I'll look it over and see if after class anybody's added stuff. Also, your projects are due today, so make sure that those get done. Just a reminder, when you go to turn it in, you're going to need to turn in 3 things, right? 1 is the worksheet portion. 2 is the link to your Google Sheet. And 3 is the rubric so that I can grade your work. So if you can get all that turned in, that'd be great. Those again are due today. This week, we're continuing with Unit 4, and we have quiz 6 due on Wednesday. And then that means also, as I said in our announcement, we've got test 4 due next week. So start thinking about that you're going to have test 4 due next Wednesday. So if you need to make an appointment on the Libby campus to take your test, make sure you stop by and see Janet or Seth, I think his name is, okay, and make an appointment with them so that you'll have a chance to take the test. Obviously, if you're on the Kalispell campus, like usual, you just go in and take it. Let's see. Any other questions for me before we get started? Okay, so we finished 4F on Wednesday, and so now we are picking up with 4G. So 4F was solving systems of equations using graphing, and now 4G and 4H are 2 ways to solve systems of equations algebraically. So we look at the notebook page. So it kind of looks similar to begin with the notebook page. So we've got those graphs that just show what those types of solutions look like, right? So we're going to solve using substitution for our first method. And so in order to solve a system of equations using substitution, you first want to isolate one variable in one of the equations. Substitute the result from the first step in for the same variable in the other equation. Solve the new equation for the remaining variable. Substitute the solution from step 3 into either the original and check your solution. Again, it's all nice and dandy when they write it out, but what does it really look like as we're doing this by hand? Again, we're going to come up with possible solutions. It's possible when we solve these systems, we'll get one solution. That would be like when we have the 2 graphs where the lines intersect at a single point. It's possible that we'll get no solution. And when we're solving these algebraically, we're going to get some sort of weird contradiction that's something like 0 equals 1 or 3 equals 5 or something that's just not true. And that's going to lead you to say that there's no solution. And that's where, again, we would have parallel lines. Or we can get an infinite number of solutions, which is where we get something that's redundant. And that's where, for the example, I have 0 equals 0, or we'll get 1 equals 1, or something along those lines. So again, think about these steps that I'm talking about that you would go through and watch how they apply to what we're going to do here. So we want to isolate one variable in one of the equations. If we look at number 1, we can see that y is already isolated. Okay. So what we want to do is look in the other equation for y, which is right here. And what we want to do is we want to take the stuff that y equals and we want to substitute it in for y in the first equation. So what does that look like? Well, instead of writing x plus y equals 5, we're going to write x plus 3 equals 5. So again, we know that x plus 3 is equal to y in the second equation, and we have a y in the first equation. So we replace the y in the first equation with what y is equal to in the second equation. We can rewrite this not using the parentheses. And then we want to combine like terms. So I've got x plus x, that's going to give me 2x. And now I'm just going to solve for x. So we're going to subtract 3 from both sides. Bring our 2x down because we didn't do anything with that. 5 minus 3 is 2. Divide by 2. And we get that x equals 1. So we have solved for x. Now, if we go back up to our steps, it says substitute the solution from step 3 into either of the original equations to solve for the other variable. What they mean is let's solve for y. So when we look at our two equations we already have y isolated in this second equation, right? So if we use that second equation and we substitute 1 in for x, we can solve for y. So since we get a single number for x and a single number for y, that means our solution is the point 1, 4. Now, how does this relate to what we were doing? So instead of graphing these by hand really quick, I'm going to use Desmos, which is a way to graph them just visually. So if I use my first equation, I have x plus y equals 5, which gives me this line, right? Now, if I put my second equation in, y equals x plus 3. If I go right here to where these two lines intersect, I can see that the point is 1, 4. So if I had solved these using what we did in 4F, meaning we graph the two lines, we find the point of intersection, we would have come up with the same solution. This is just a new way to solve them, not using graphing. We're using algebra instead. Okay. So let's go back to our notebook page. And look at the next page. So number 2, we have y equals 2x minus 5. Again, really nice. We've already isolated one of our variables. The second equation is 3y minus x equals 5. So again, we've isolated a variable. That means we can substitute in for that variable in the second equation. So if we do that, we've got 3 times y, but y is equal to 2x minus 5, which we know from the first equation, right?
Could we hop pages? The screen share is on your Desmos. I don't know if that was intentional, but.
No, I thought I shared. Oh, it didn't change over. There we go. Can you see it right now? Okay. I selected it. I guess I didn't want to do it. So again, first equation tells us what y is equal to. Looking at the second equation, we can replace that y with what y equaled in the first equation. So plugging that in, we have 3 times what y is. We'll complete it by saying minus x equals 5. So remember, when we have a value in front of the parenthesis, that means that it's multiplying everything inside that parenthesis, which means we need to distribute the 3 through. So we're going to do 3 times 2x minus 3 times 5. And then we finish out the equation, right? We bring down the minus x and the equals 5. You can't forget all that business. So simplifying, 3 times 2x is going to be 6x. 3 times 5 is 15 minus x equals 5. So now we want to combine like terms. So if it helps to rewrite them so they're all next to each other, you can do that. So all I did was move the minus x from the end of the equation up to the front. So I had 6x minus x, which reduces to 5x minus 15 equals 5. So I'm going to let you finish this problem from here. I want you to solve for x. substitute back into the first equation and solve for y, and tell me what you get as your solution as an ordered pair.
So when you get the points, would they be in parentheses, like next to each other? Like it wouldn't be separated like by zero, like zero before a number or after?
No, they're in an order pair.
Okay.
So it's just like the x value, comma, the y value. Okay, so if we add 15, bring our 5x down, we get 5x equals 20. Dividing by 5, we get x equals 4. So now we go back to the first equation, which is y equals 2x minus 5. Again, we have our y variable isolated. That's what we're trying to solve for now. So we're going to take this 4 and we're going to substitute it in for x in that other equation. So we get y equals 2 times 4 minus 5. 2 times 4 is 8. And 8 minus 5 is 3. So our solution is the 0.43. Okay. So 1 and 2, we already had a variable isolated. In number 3, we do not have a variable isolated. When given letters that are not x and y, they're always in alphabetical order when we think about reporting the ordered pair. So this would be the comma A, comma B. Sorry, the ordered pair A, comma B would be our answer. When looking to isolate a variable, isolate the easiest one. And so what I'm saying is if you look at equation, the first equation, A minus B equals 6, versus the second equation, in the first equation, I just need to add B to move it to the right-hand side to get A isolated, versus in the second equation, I'd have to add 4B, divide by 3, that makes your life a lot harder. So let's focus on that first equation here. We have A minus B equals 6. So again, like I said, we want to isolate A. It's going to be the easier variable to isolate. So we'll add B to both sides, giving us A equals B plus 6 or 6 plus B. It doesn't matter which way you write it. Either is fine. So once I've isolated A, now we're going to take that stuff that A is equal to, we'll plug it in for A in that second equation. So we're going to have 3 times B plus 6 instead of writing 3A. And then minus 4B equals 18. So I'm going to let you finish. You will get an ordered pair for your answer. So remember, when you're listing your ordered pair, whatever you get for A comes first, whatever you get from B comes second. Okay. So let's check our process. Again, I've got 3 times B plus 6. This means I need to distribute the 3 through. So 3 times B is going to be 3B. 3 times 6 is going to be 18. So I get 3B plus 18 minus 4B equals 18. So 3B minus 4B combining like terms, this gives me negative 1B. If I subtract 18 from both sides, I end up with negative 1B equals 0. And that's a fine answer, like, right? That's possible that we would get that. When I divide by negative 1, I just get that B equals 0. Again, that is okay for that to be an answer. We get there. When we go back up to look at which equation to put it into, it's going to be easiest to do the A equals B plus 6. And the reason for that is A is already isolated. Okay, so you have 2 equations that we started with, then you have that third equation to choose from. That's a totally fine equation to use. So we'll take 0, plug it in for B, and then get A equals 0 plus 6. Therefore, A equals 6. Therefore, our solution is 6, 0. Again, the reason why it's 6, 0 is that our variables go in alphabetical order in our ordered pair. Therefore, A comes before B. So questions about number 3, because some of the answers were kind of all over the place. So I just want to see what questions we have before I move forward.
So this probably doesn't follow the order of operations here, but for some reason, just for the ease of the negative B when we're trying to find out what B means, on the step where you had negative B plus 18 equals 18, I divided the negative 1 first to make the 18 negative and then added, or excuse me, minus 18. I don't know if that makes any sense, because normally I think you'd want to do the multiplication like negative 1B, you minus your 18. So that way you get 0, whereas for some reason, I don't know why it was kind of confusing my head. I don't know if it's right or if you're allowed to or you should, but I divided by the negative first.
I see what you're saying. If you divide properly, it can work. It just doesn't, it's not a great idea because it's easy to make a mistake. So if you divided that whole thing by negative 1, you would have gotten B minus 18 equals negative 18, because you would have had to do both things on the left plus the one on the right. And again, that is valid. You can do that. You just have to make sure you're consistent. I personally encourage you to first undo the addition and subtraction, then do the division and multiplication. As long as you're consistent, it will work for you. If you're not consistent, it's a place you'll make a mistake.
Oh, totally. And that's probably why I felt so weird. I was like, I don't think I'm really solved these this way, but it worked out this time. I got lucky.
Oh, yeah. Any other questions? Okay, let's look at number 4. So number 4, we have a variable isolated already, right?
I had a
X
question.
equals, oh, sorry, Robert, go ahead.
Yeah, I was messing with my mute. Would it have mattered which equation we used to figure it out?
What do you mean?
Like we used the 3a minus 4b to find both a and b. Could we have used the other one too?
Well, we didn't use it to find both A and B. We used it to find B, and then we used the first equation to find A. We could have plugged 0 in for B into 3a minus 4b, meaning we could have had 3a equals 18, which would have still given me a equals 6. And that is fine because this is a solution that works for both equations. Did that answer your question? Okay. Any more for number 3 before we move forward? Okay. So number 4, we have X isolated, so we can go ahead and use it as it is. We don't have to do any extra work. So what that means is that X is equal to 2y plus 1. So we're going to plug that in for X in the second equation. You always have to go from the first into the, like you have to go opposite when you're substituting, okay? So if I plug that in for X, I'm going to have 3 times 2y plus 1. Then we finish out the equation with the minus 6y equals 2. When I distribute the 3 through, I've got 3 times 2y, which gives me 6y. 3 times 1 is 1. Nope, that's not true. Ooh, that's an easy mistake, right? We forget. We have to multiply there. 3 times 1 is 3. Minus 6y equals 2. Now you can kind of see where we're leading here, right? Because I've got 6y minus 6y plus 3 equals 2. 6y minus 6y is 0y, which just means the y's drop out, leaving us with a statement that 3 equals 2. And that is not true, right? This is a contradiction. Which leads us to say that there is no solution because these are parallel lines. So this isn't a situation where we've got a special solution, right? Number 5 is another example of a special solution. So again, with number 5, I have a variable that's isolated. I'm going to take this stuff, y equals 3x minus 1. So I'm going to take the stuff that y equals, and I'm going to plug it in for y in the second equation. Do 6x minus 2 times 3x minus 1 equals 2. A suggestion to you here, we're multiplying everything inside that set of parentheses by -2. So maybe rewrite this as plus -2 times 3x minus 1. The only reason why I'm saying that is because you can't forget to distribute that minus to both terms. If you don't distribute it to both terms, you'll end up making a mistake and you're not going to get the right answer. So I'll show you why that's important. We're going to distribute to the 3x. We'll distribute to the -1. So -2 times 3x is -6x. -2 times -1 is +2. Combining our like terms, the x variable drops out because 6x plus -6x just is 0x, which is just 0. And we get 2 equals 2. If we had not remembered to distribute that negative through, we would have ended up with a -2 equals +2, and you would have told me that there is no solution. When really, this is a redundancy, meaning 2 equals 2. Sure, I know that already, right? Like that's we're restating the obvious. And that is because these are the same line and we get infinite solutions. And then remember, in my math lab, along with that infinite solution option, if you're choosing that as your answer, it's going to have your answer written in set notation, where it says it's the set of x, y's, or the set of ordered pairs, x, y, such that they lie on the line y equals 3x minus 1. Again, that's not something you need to remember how to write out. I just want you to know that that's part of it. That's part of the way that we describe the solution set. When we have an infinite set of solutions, the reason why that is that there's an infinitely many points on a line. Okay, and it's all the order pairs that live on that line are the infinite solutions to this system. So again, important step, make sure you distribute that -2 through. That negative sign has to hit both terms. If you don't, you can end up with the wrong answer, right? So questions about number 5 before I move forward. Okay. All right, I'm going to let you do number 6 on your own. I'm going to tell you, you will get a single point as your solution, meaning you will get a number for X, you will get a number for Y. So I want you to go ahead and solve that one on your own. Send me your solution as an ordered pair. So when thinking about how to attack this, think about what is the easiest variable to isolate, okay? So when I look at these, the thing that stands out to me is that in the first equation, x does not have a number in front of it, meaning x is all by itself. We just need to move the y over. So if we take that first equation of x minus 2y equals 5, and we add 2y to the right-hand side, I get x equals 5 plus 2y. The reason I like doing this is that it means that I don't have to divide by a number to isolate that variable. So if I were to try to isolate y in the first equation, I'd have to divide by -2. If I was trying to isolate y in the second equation, I'd have to divide by +2. If I was isolating y in the first, or the x in the second equation, I'd have to divide by -3. Again, look to do the least amount of work to isolate that variable to begin with when you're trying to start this whole process. So because I isolated x in the first equation, I can't plug it back into the first equation. I have to now go and put it into the second equation. What I mean is we're going to take this 5 plus 2y, we're going to go to that second equation and we're going to plug it in for x. So I've got 2y minus 3 times 5 plus 2y. Okay, so we have an opportunity to make an easy mistake here again, right? That whole distributing of the negative. So I'm going to distribute the -3 to both terms, meaning we're going to have 2y minus 15 minus 6y. Again, that comes from -3 times 5 is -15. And -3 times 2y is -6y. Okay, and that's going to equal 1. So now let's combine our like terms. If you need to gather them together first, meaning rewrite the equation so those variables are together, that's fine. 2y minus 6y is -4y. We're now going to add 15. And I'm running out of room, so we're going to carry on up here. So I have -4y equals 16. Dividing by -4, I get y equals -4. Because it's positive 16 divided by -4 is -4. So I'm pause there. Any questions so far? Okay. Again, when looking for where to plug this back in, you do have 3 choices, meaning we could plug it in to this first equation, we could plug it into the second equation, or we could even plug it into the third equation. The reason I like the third equation is because x is isolated, and that is what we're trying to solve for now. So if I use the equation x equals 5 plus 2y, and I plug -4 in for y, I get x equals 5 plus 2 times -4. Simplifying that multiplication. So I have 2 times -4 is going to be -8. And 5 plus -8 gives me -3. Therefore, our solution is the point -3, -4. So pause. Let's ask questions.
Again, I think
Go ahead.
again, I think it's just maybe different orders of steps here, but for that one, what was it? I did like x minus 2 parentheses -4 equals 5, and then obviously, you know, the negative times negative equals positive. I guess that obviously works, but
Yeah.
it's different from what you wrote down here. But
No, and that's what I was saying. You have, like, you see how I have those 3 green check marks? You can use any of those 3 equations to solve for X. I just
Okay.
chose the last equation because X was already by itself. That's the only reason I chose it. Not because it's not going to work if you put it into any of the other ones. It's just, that's the reason why I chose it. So your method was fine. No issue with that. What I was going to say is that you'll still get the same answer if you were to isolate Y first. You would have been dealing with fractions though, which would have made your life a little bit harder, and it could have led to opportunities to make mistakes. That's all. But you would still theoretically get the same answer. Did anybody try to solve for one of the other variables first and they wanted to see where they went wrong in their work if they didn't get the right answer? Or
I just kept forgetting to pull down the negative sign with me as I went.
oh yeah, I do that all the time. All right, let's look at number 7. So up to this point, all of our solutions have been integer solutions. It's possible to get fractional solutions. So I don't want you to go through this and get a fraction and be like, oh, well, I clearly screwed up. Well, no, it is possible to get a fraction. And in your homework, just a little hint, on number 8, you're gonna get a fraction. On number 11, you're gonna get a fraction, okay? Or at least those are how my answers come out. So I'm assuming they're probably gonna be the same for you. So what does that look like? So when we look at number 7, it doesn't matter which variable we isolate. We can use the first equation and isolate X. We can isolate Y. It doesn't matter. I am lazy. It's the only thing when I look at this, I go, what is the least amount of work for me? And when I look at that first equation, all I have to do is add Y, right? So in my mind, let's isolate X in the first equation. So if I have X minus Y equals 5, I'm going to add Y to both sides, giving me X equals 5 plus Y, or Y plus 5. It doesn't matter how you write it. It's still going to work, okay? I'm then going to take that 5 plus Y, because it's equal to X, and plug it in for X in that second equation. So we'll combine like terms. And then we'll solve for Y. So we'll subtract, oh, what did I write? That needs to be 7. So if we subtract 5 from both sides, bring our 3Y down, we get 3Y equals 2. If I have 3Y equals 2, that means Y equals 2/3. That's a valid answer, because remember, when we're thinking about graphing these points, there's infinite points on the line. We like to look at the ones with their integers, right? That's where the little lines intersect, but there's those dots that are in between there. Those are fractions, those are decimals, those are possible solutions here. So we need to solve for X, right? Again, I'm lazy. The only reason why I'm doing this, I look at this equation right here and go, oh, X is already by itself. Let's use that one. So I have X plus 5. X equals 5 plus Y. Let's plug 2/3 in for Y. Now we could easily just write this as 5 2/3, because it's 5 wholes plus 2/3. Your homework wants you to write them as improper fractions. So that means we need to come up with a common denominator here. So if I take 5, which is 5 over 1, and I multiply it by 3 over 3, I end up with 15/3. The reason I want to do this is so that I can add those fractions together, giving me 17 thirds for x.
I have a question. Wouldn't 5/1 be multiplied by 2/3?
Why 2/3?
Because that's what y is.
But I'm adding them together, not multiplying them. So in order to add fractions, you need to have common denominators, right? So I need to turn 5 into a fraction that has 3 as the denominator. So in order to do that, I multiply it by 3/3. 3/3 is a factor of 1, so I'm not actually changing the value of it. I'm just creating an equivalent fraction. So that's how I get the 15 thirds. So once I have the 15 thirds, then I can add 2 thirds to it, giving me 17 thirds. So then my solution is 17 thirds, comma 2 thirds. Because again, we're adding, right? Not multiplying. So just because you get a fraction doesn't mean it's automatically wrong. Obviously, if you put that answer in and it yells at you, then it's wrong. But it is possible to get fractional solutions here. So solving these systems of equations as just the set of equations I've given you is very much a vacuum situation. But we want to be able to apply this to word problems. So if we go to the next page, we have in that information box some reminders. So definition about complementary and supplementary angles. So two angles are considered complementary if their angle measures sum to 90 degrees. So if I have angle X plus angle Y, they're going to equal 90 degrees. If I were to draw that, 90 degrees looks like this, right? So in here, I have angle X and angle Y. When I add them together, they equal 90 degrees. Versus supplementary angles, our two angles are considered supplementary if their angle measures sum to 180 degrees. 180 degrees is how many degrees are in a straight line. So if I have two angles, X and Y, if I add them together, they equal 180 degrees. The only reason why we're learning this is just so we can solve the word problem that has this association with it, okay? So in number 8, it says two angles are supplementary. We're going to use this first statement or this first sentence to write our first relationship, which is that X plus Y equals 180. You don't really need the degree mark. But we're writing a system of equations to represent what they're saying here, and then we're going to solve the system. The second sentence says one angle measures 30 degrees more than twice the other. So when I read this, I read one angle measures 30 degrees more than twice the other. So more than means added to, twice the other is 2 times that amount. So what that means is we have a system that says X plus Y equals 180 and Y equals 30 plus 2X. So now once we've interpreted the word problem, we're given that system, and then we can kind of forget the rest of it, right? We're just solving the system as it is. So I want you to go ahead and solve that. Send me what you get for X and Y. Okay, so if we look at this, we already have one of the variables isolated, right? In the second equation, y is by itself. So what that means is we can take that stuff that y equals and plug it in for y in the first equation. It's possible to do that. We've been focusing on isolating in the first equation and plugging into the second equation. It doesn't really matter the order they're in. We're just looking at, can we isolate a variable, plug it into the opposite equation, and solve. So if we plug that in, we're going to get x plus 30 plus 2x equals 180. Again, I'm substituting the 30 plus 2x in for y in that first equation. If I gather my like terms together, I have x plus 2x, which is 3x. Subtract 30 from both sides. Bring our 3x down. 180 minus 30 is 150. We'll divide by 3. And we get x equals 50 degrees. So then we want to solve for y. There's two ways we can do it. We can do 50 degrees plus y equals 180, right? And then subtract the 50 off, or we can use that second equation where y is already isolated, plugging 50 in for x. 2 times 50 is 100, and I get 130 degrees for y. So when you go to answer, there is a question like this on your homework, and instead of it saying like this first angle and the second angle, it's going to say the measure of the smaller angle is blank and the larger angle is blank. So make sure when you're putting in your answers, you make sure you check for what it's saying, right? So if it says the measure of the smaller angle is, you would say 50 degrees, right? Because 50 degrees is smaller than 130. The larger angle is the 130 degree angle. Questions about number 8? Okay. So with these problems, they tend to have two sentences that sort of set up your equations. So here's what I mean. The first sentence in number 9 says the difference between two numbers is 18. First of all, the word difference means subtract. So the difference between two numbers is 18, meaning I'm just going to write x minus y equals 18. The word is, treat like your equal sign. By doing this, we're declaring that x is larger than y here. Because we're saying we're taking y off of x, therefore x has to be bigger. And how much bigger? By 18. So knowing that, that means that y is the smaller number. So when we look at our second statement, it says twice the smaller number plus 3 times the larger is 74. So twice the smaller number, 2y, plus 3 times the larger, 3x, is 74. So now we have the system that says x minus y equals 18 and 2y plus 3x equals 74. I'm gonna let you solve it. Tell me what x equals, tell me what y equals. Oh, why did I write 77? I apologize. This is 74. So we get 22 for X and 4 for Y. Again, when we report these, it's going to say the smaller number is, the larger number is. So make sure that you put them in with, 4 being the smaller number, 22 being the larger number. Okay. All right, last problem for this section, and then we're going to get a little bit into 4H. So Molly ordered a poster printed for her prize-winning photograph. The poster had a perimeter of 100 inches, and the length was 6 more than the width. Find the length and the width. So first of all, let's think about her poster. Here's her poster. It's of mountains with some snow and a sun. Beautiful. Prize winning. Okay. So perimeter means the distance all the way around. So it's a length and a width. So the perimeter is equal to 2 lengths plus 2 widths. Instead of using P, we're going to put in the fact that the perimeter is 100 inches. The other piece that they tell us is that the length is 6 more than the width. So we know if the length is 6 more than the width, we can now substitute the 6 plus W in for L. So we're going to say 100 equals 2 times 6 plus W plus 2W. Again, we'll distribute here. Combine like terms. And then we can solve for W. So we'll subtract 12 from both sides. 100 minus 12 is 88. Divide by 4. And we get 22 inches is equal to the width. We can't solve this problem without knowing the relationship between perimeter and length and width, right? And that comes from the distance all the way around it. Okay, we can go back and solve for the length by saying that it's 6 more than the width. So it gives us 28 inches. So again, this is one where you need to make sure that when you're entering your answer, make sure you pay attention to where it says the length is blank, the width is blank, and then we enter the answers accordingly, right? Because you could have the answer right and you just put them in the wrong positions and it gets mad at you and then you get frustrated and I can't help, right? So that was substitution. We're now going to take a little look at elimination. Some people like elimination better, some don't. I tend to go with substitution. Like if I am given a system and I have to solve it, I just automatically go to substitution. But elimination is nice too. So what happens with elimination? So to solve a system of equations using elimination, we want to first get both variables on the same side of the equal sign for both equations and the constant terms on the opposite side, meaning we want X and Y together and whatever they equal on the other side. That's what we're trying to say. We're going to choose a variable to eliminate. We're going to multiply by an appropriate constant if necessary, so that the coefficients are opposites, meaning one's a positive and one's a negative. And the sum of those variables when the equations are added together becomes 0. We're then going to add the two equations and solve the new equation for the remaining variable. So when we add those equations, one variable is going to drop out and we're going to be left with one variable left and we're going to solve for it. Then we use substitution, much like we did in the last method, to solve for the other variable, and we check our solution. FYI, the elimination method is also referred to as the addition method. Your homework will reference both of them when solving them, so I just wanted you to be aware of that. Again, possible solutions. We get one solution, nice ordered pair. Or we can get no solution, where again, we'll get a contradiction like 0 equals 1. Or we can get an infinite solution where we get some sort of redundant. See, we're like 0 equals 0, 1 equals 1, 2 equals 2, blah, blah, blah. Again, this is one of those types of things where it makes more sense to just do it than try to read through the steps. So when we look at number 1, I want you to focus on y here. In the first equation, I have plus y. And in the second equation, I have minus y. So I have plus 1y and minus 1y. So what we're going to do, first of all, we can see our equations have x and y on the same side. They also line up together. Because I have variables that are already opposite of each other, right? See, the y's are opposite. Because they have opposite signs and the number that's in front of them is the same, meaning one's a positive 1 and one's a negative 1. When I add these two equations together, we're going to add vertically. 2x plus x gives us 3x. Positive y and negative y gives us 0y. 7 plus 8 is 15. We don't need to worry about the 0y because 0 times y is just 0. So what this really leaves me with is that 3x equals 15. So we have eliminated the y variable here. So this is where they talk about you add them together and then you're going to solve for the remaining variable, meaning I have 3x equals 15. So I'm going to divide by 3, giving me x equals 5. One of the reasons why I like the substitution method better is that you have an equation where one of the variables is already isolated. So when you go to solve for that, there's not a lot of extra work that has to be done. With the elimination method, you're not going to necessarily have it. It doesn't matter which equation you plug x back into, you're still going to get the same y value. So if we focus on the first equation, I've got 2x plus y equals 7. So if I take 5 and I plug it in for x, I'm going to have 2 times 5 plus y equals 7. 2 times 5 is 10. Plus y equals 7. We will subtract 10 from both sides. Bring our y down. And I get y equals -3. Which means I have a solution of 5, -3. It's a weird thing to do, right? And there's times when the substitution method makes sense and the elimination method makes more sense, okay? But we want to make sure you know both. So they're not always going to be that nicely set up to begin with, is what I'm trying to tell you. Like in this one, we didn't have to do much. We just added the equations together and we were good to go. But let's look at number 2. First of all, when I look at number 2, I say, oh, nice, y is isolated. Let's just use the substitution method. But we can't because we're practicing elimination, okay? But this is an example of if you were given the option of using either method to solve it, you would want to go towards substitution. Where the first equation, because the variables were already on the same side of the equal sign, they were already opposite, that's a good place to use elimination. Again, practicing, we're going to make elimination work. So the first thing we want to do is we want to move the 4x to the left because we have to get x and y together on the same side of the equation. We're going to move that way. In order to move it that way, we have to subtract it. So we're going to have -4x plus y equals 3. Again, all I did was I subtracted If you need, if you're like, what did you do, Aaron? I'm lost. We subtracted 4x from both sides. I got negative 4x plus y equals negative 3, right? Now, if we look at our second equation, I have x minus 2y equals 8. If I were to try to add these together, neither variable is going to drop out. Negative 4x, positive x makes negative 3x. Positive y, negative 2y makes negative y. They're not going to work. So what we have to do now is we have to multiply one of these equations by a number that will cause it to then cancel with the variable in the other equation. So we have two choices. I can either multiply my first equation by 2. If I multiply this first equation by 2, how does that help me? Well, 2 times negative 4x gives me negative 8x. 2 times y gives me 2y. And 2 times negative 3 gives me negative 6. Why does that help me?
Where did you get the negative 3 from the original equation? Just sorry. Isn't it going to
Oh,
be?
it's positive 3. Thank
Cool.
you. There we go. Thank you. That's easy to get everybody confused. You're already confused enough. We do not need to add to the problem. So we have positive 6, right? Why did that multiplying by 2 help us? Well, if we take that second equation and we write it underneath, what happens to our y's? They're now opposites of each other, right? So if we add them together, negative 8 plus x, negative 8x plus x gives us negative 7x. Positive 2y, negative 2y cancel, and 6 plus 8 is 14. So now we have this nice little baby equation that says negative 7x equals 14. We can solve by dividing by negative 7. And positive 14 divided by negative 7, we get x equals negative 2. So now what do? We got to solve for y, right? When I look at all the equations I have to choose from, I can go into this very first one. I can go into this second one. I can go into this third one. It does not matter. I like the first one because y is isolated. So if I take y equals 4 times negative 2 plus 3, I get negative 8 plus 3, which equals negative 5. So then I have a solution of negative 2, negative 5. Before I do number 3, I want to show you that it doesn't matter which variable you cancel out first. So remember I had negative 4x plus y equals 3 and x minus 2y equals 8. And I chose to multiply the first equation by 2, right? And that's what allowed me to cancel the y's out. Instead, I could have multiplied the second equation by positive 4. That would have been a valid move. If I had done that, I would have had 4x minus 8y equals 32. Keeping that first equation as it is, I could have added them together. The x's would have dropped out instead, giving me negative 7y equals 35. Dividing by negative 7, I would have ended up with y equals negative 5. We still would have gotten the same answer. It doesn't matter which variable you decide to eliminate first. You're always going to get to the same answer because it is the point where those two lines intersect. Okay. So if we had done that, again, it doesn't matter. We can then plug it in and we would have gotten x equals -2. We did a lot today. I want you to let this kind of all sit in your brains and stew about. And then we will come back to it on a day. When are we coming back to it? On Wednesday. So we will do 4H and 4I. We probably won't get through all of 4I on Wednesday. So on Thursday, my plan is to go through the most commonly missed questions from the quiz and actually from both quizzes, and then finish up whatever parts of 4I I don't finish on Wednesday. Okay, so we do have our session Thursday. And so we'll go over the questions from the two quizzes, last week's quiz, and then this week's quiz, which you have due on Wednesday. And then any bits of 4I that I don't finish on Wednesday, I will finish up on Thursday. Questions for me before we go? Okay.
I do have a quick question, but it's about the flight predictability if anyone else would like to leave.
Okay. Well, I'm going to answer Bria's question about flight predictability. If you don't have any other questions, feel free to sign off. I hope you all have a good day. Again, projects are due tonight, so don't forget. All right, have a good one, everyone.